Hello, everyone, and welcome to Simplify Network Automation with NetGrew. I'm your host, and today we're continuing our month of Cisco content, of Cisco learning that we started a couple of weeks ago. So we're on week 3, and our guest today is Gabi Zapodiano. Gabi, hi, how have you been? It's a pleasure having you always here. Welcome to Simplify Network Automation with NetGrew. I'm your host, and today we're continuing our month of.
There's a little bit of a background. I don't know if it's from me, but hi, everybody. I'm very happy to be back here. Today, we are going to talk about a very hot technology, something that is of very high interest for all of us, the network engineers. We are going to look at MCP servers and how to use them across multiple platforms. I'm going to showcase integrations with both Catalyst Center and Meraki, with multiple Catalyst Center clusters and multiple Meraki organizations. So how's everybody doing this morning?
Doing well. Sorry about that. There was a bit of background noise here. I managed to stop it. So yes, doing well, Gabi. Thanks for coming back on the stream. So yes, I know you've been busy, right? You've been doing lots of AI work. Tell us a bit about what you've done around AI so far, and what I know you're excited about it. So what do you think about it?
I think it's a very transformative technology for all of us network engineers. For those that do not know me, I am a network engineer for a very long time. Same with Adrian.
Yeah.
I have been doing APIs for probably, it's almost 10 years now. I have started with APIs with platforms that do not exist and migrated, of course, to the current controllers we have. For the last probably a year and a half, I started to focus a lot more on AI. Primarily because it is very innovative, but also it allows us to use everything that we have built from a network platform perspective for the many years, all the APIs, all the integrations we have, and actually allows us to innovate faster and consume these APIs in a much easier way. Of course, AI enables a natural language interface for us, the network engineers, for multiple use cases, either if I'm looking for network insights, either if I'm looking for troubleshooting, I'm looking for information across multiple clusters like Catalyst Center or multiple platforms, Catalyst Center and Meraki, or maybe I'm interested to configure infrastructure. I have presented a number of sessions at Cisco Live. Some of them are focused on retrieval augmented generation, on AI code generation for Ansible playbooks, for example, or Python SDK workflows using different platforms. I have also presented on tool calling and function calling. And that's where now we are speaking about MCP servers, because I do believe maybe the initial use cases that we developed for tool calling or function calling are so much easier to be developed or actually create new ones with MCP servers. So I do believe for all of us network engineers or for the developers that are on the call, MCP servers and network automation are a good match. We just need to be obviously careful, basically start working on the first use cases, the ones that are very important and easy for us. Maybe migrate in time for configuration of network infrastructure. We just need to target the proper use cases and have the right policies in place for those use cases.
Yeah, and I mean, I don't know, Gabby, if you've seen anything like this before, but the way AI evolves basically from one day to the other, right? 1 week to the next, just the amount of the evolution that we're seeing in the accuracy of the LLMs, right? In the power, in what they're capable of doing.
Time anything like this.
Exactly. I've not seen in more than 20 plus years now that I've been in the industry, right? I've never seen anything evolving this fast and making so huge steps, right, in such a short amount of time. So it's really exciting to see where it's gonna go next, right? So it's incredible.
Yeah, absolutely. Like, but I have been working with. We had different hackathons that I have been working 6 months ago with network troubleshooting and trying to use different language models and reasoning. And it was probably enough at that time. But if we fast forward
I
6
think you're
months
cutting
later,
off a bit.
these models are so much better. And these are large language models were specific for Cisco infrastructure. So the progress of different tools that are available for all of us to use has been absolutely fantastic. And it's exciting. We live through times where the innovation all around us is so great, and we just need to capture this and use it for our day-to-day work to really simplify what we do with when we manage networks, but also have much better understanding of how to manage the network, how to optimize them, and getting to the insights we are looking faster.
All right, so you were cutting there a bit at the beginning, but then the rest of it came through. So we got the message. All right, so then let's talk about MCP, right? And I know you have some slides. Let me bring in the screen.
I have some slides, and then definitely we'll get to demos and take a look at some code. Let's start with why MCP servers, why they are important for us as network engineers. Because with an MCP server, we have the option to create new use cases, and it's fairly easy, or reuse existing workflows, existing network automation tools that we already have developed for many years. If we look from an MCP protocol perspective, the Model Context Protocol, it is a standard. It is not necessarily a traditional standard in a way that we are familiar with IEEE or RFCs. This is an open source standard. Is a very good recommendation of how agents would interact with multiple servers and offer us as humans a natural language interface to access these tools from different servers. If we look from me as a network engineer, I'm going to interact with an AI agent. This agent has a large language model. We'll use the library for the MCP client to actually call, in our use case, call APIs of different network controllers using basically the MCP server. So me as human, I'm asking a question. The AI agent using an LLM understands the question, looks for the proper tool, will use the MCP client to instruct the server that will make those calls, the API calls, to my network controller. Again, tools could be new that we are going to build, or could be existing. Maybe I have an Ansible playbook, let's say a Cisco Ansible workflow that has been developed by our Cisco engineering. They are published with the Ansible collection. I want to run those Ansible workflows via an MCP server. It is very easy to do that. For the purpose of the demonstrations today and the session, the talk, we are going to consider the AI agent and the MCP client as one client application, and that's the one that you're going to see today. I'm using Cloud Desktop. This talk is focused primarily on the server and the best practices and how to build actually the server. Of course, when we start to see some of these applications in production, the large language model probably wouldn't be the one that I will use today. There could be other variations depending on your policies, what type of large language models you already use and you feel comfortable with. If we look from a multiple platforms perspective and multiple controllers, in this case, we have on-prem and cloud, the MCP protocol allows me to communicate from a client app perspective with multiple servers. And I could have one Catalyst Center cluster, maybe a second cluster, and maybe Meraki with multiple organizations as well. When the client app starts, in my case, is Cloud Desktop, it will communicate with all of these different servers and will understand what are the tools available from each of the servers. And those tools is the tools list is what the client app will use to map my query, my question to one of these tools. So let's start to take a look a little bit deeper in the workflow. The client connects to the MCP servers and discovers available tools. This is what the MCP protocol does. It informs the client application of the services that are available. So for example, I could have an MCP server that runs Ansible playbooks for network configuration. I may have another MCP server that could be for network insights, for network inventory, and maybe I have a cloud MCP server that offers me information about the Meraki infrastructure. All of these different tools are going to be advertised, and the client application will use them to match the intent that the client will have, the human will have. So if I submit a question, hey, I'm looking for provisioning a network device, maybe that question will be routed to one of these MCP servers that, let's say, will run an Ansible playbook. If I have another question, I'm interested in a Meraki client connected to, let's say, one of the networks I have, then the large language model would understand, based on the available tools, which is the tool that should be executed and what MCP server will run that call. So in this case, will be routed to the Meraki MCP server that will call the Meraki API dashboards, dashboard APIs, and run the API call. Again, it is the same process as I already described. It receives the question, looks at all the tools that are available, and identify the proper API call, the proper tool, the correct tool that will execute, will provide the information that I'm looking for. Now, there could be situations where I have lots of different tools that the MCP client, the client application actually may not identify from first attempt the correct tool. And depending on the logic of the large language model and the client application, it may try one or two different tools, or for some workflows, for some questions, I may need to call multiple tools from different servers. So for example, if I'm asking, and I think we may be able to do a demo on this today, give me information about this client. And I don't know where the client is connected. It could be connected to one of the few Catalyst Center clusters that I have, or maybe connected to Meraki, to one of the organizations that I have access to. So I could have a question, give me information about this client, and the client application will then go through a process to identify where the client is connected, calling different APIs from multiple Catalyst Center clusters and multiple organizations until it finds the information that I'm looking for. So sometimes the MCP servers will execute calls depending on really not only from one MCP server. The client application may require multiple tools from multiple servers to provide me the information that I'm looking for. And that is the power of MCP as a protocol that allows me to, with ease, to bridge the gap between different controllers. Multiple controllers could be the same, multiple Catalyst Center clusters, or multiple Meraki organizations, and really unified the experience of the user when managing both on-prem and cloud infrastructure.
And Gabby, also the LLM learns, right? So if it doesn't know on the first try exactly the tool, as you customize your prompt and you make it more specific or give it more information, right, you can kind of guide it and point it in the right direction. And then it can learn. And next time it would know that, oh, this tool provides me the fabric ID, for example, right? If you didn't know in the before.
Yeah.
Right.
And there, yeah, you're right. And there are different options. We can help the large language model to be more efficient, or the client application. So one is, if I have a conversation, can you hear me okay? Or
yeah.
Yeah, so if I have a conversation, of course, during the conversation, everything is cached. And in reality is, when we have a conversation like we have now, we have history. We know what we talked in the past. And the same is for all the client applications, should have a history that is used to match to the correct tool. And for example, if in a conversation I ask information about network devices, let's say from Meraki, it gives him that information, which means it already knows what organizations I have access to and all the networks that I have access to. And then if I have a question about clients connected to a specific network device, it already uses the information it learned. So that's a very basic cache. Like, it knows, well, I have these networks, network devices and networks. Let's find the clients for each network. Then obviously the other path that we have is, and maybe we'll get a little bit in the conversation toward the end of the talk, I collect telemetry of what API calls are being made to my infrastructure. And collecting that telemetry within the MCP, within the client application, allows me to learn, for example, me and you, Adrian, are making a lot of calls to get fabric information, fabric devices information, and maybe we don't have a tool for that. And that's how we will, looking through telemetry, we can identify the high demand, the APIs that are in high demand that are successful, and we build a tool. Maybe some API calls are not successful because the parameters provided are incorrect. So we can learn how to optimize this infrastructure to make it as efficient as we can. Obviously, requires a little bit of time to put in, but for the outcomes, for what we can do with MCP servers, that time is very well rewarded at the end. We are going to have very good return for our investment,
as we'll see in the upcoming demos.
Yeah, we will see. So let's start to look a little bit of some use cases, and definitely I would like everybody, or if you have questions, or prioritize what are some of the use cases that you are absolutely interested to see developed. And everything you are seeing here, it's likely already available from a proof of concept perspective. We are looking to release MCP servers for both Catalyst Center and Meraki. And we are looking to prioritize some of these features, some of these capabilities, what would be useful for all of us as community to use from a tooling perspective. You can see here on the right-hand side some of the available network management tools that I already have built. This is just a subset. I have more tools available today than what you see there, but this is an idea of what type of tools you can see. So how important is, obviously, I think this is a default for the agents to have access to multiple MCP servers, but are there any situations where maybe there is a need for an MCP server to access only basically a Catalyst Center cluster, for example, or a Meraki organization, or maybe an agent to have access to only one MCP server? So if some of the attendees are working in highly restricted environments, maybe air-gapped environments, they cannot connect to the internet, there are very strict requirements as far as what AI tools may have access to. Certainly, it is possible. We can configure the client, use only one MCP server. That's super easy. And if that MCP server should have access to only, let's say, one Catalyst Center cluster, or maybe only one Meraki organization, that's certainly possible as well. So for those that we cannot access multiple organizations or multiple controllers or multiple MCP servers. Certainly it is possible. But I think for most of the network engineers, the ability of connecting to multiple clusters or Meraki organizations is very important. Let's start to get a little bit more in use case, in tools. So a tool could be just one API call. So for example, if we look here on the right-hand side, the first Meraki tool is list organizations. I want to see the organizations that I have access to based on a specific API key, which will be one organization. So could be one API call, or could be a sequence of few API calls that are predetermined, pre-coded, pre-defined, and provide me the answer that I'm looking for. So some of the tools could be very simple. Some of the tools could be a little bit more complex. But for the purpose of network management, for network automation, tools and API calls are very easy to build. If I have a tool for, let's say, getting the site count for Catalyst Center, it's one API call. Using these tools that we already have, which are very simple, straightforward, we can build what I call generative AI flows. So for example, I know for network troubleshooting, I need to go through few steps. So if I'm troubleshooting using Catalyst Center, I need to get the active issues. I need to identify the devices that are impacted from a topology perspective. I need to run recommendations from assurance, how to execute suggested actions. Maybe I want to do some show commands, additional show commands for the issue. I want to identify if any configuration changes have, basically, if anybody made a configuration change on the device. So there are few steps that I would do every time that I'm troubleshooting a network issue. So a generative AI flow would be able to use existing tools, the tools that we have above, that are one API call, and run all of those tools in a very simple sequence. All I need to do is declare, run these 5 tools in this sequence, and that's a generative AI flow. So it's very simple to automate using MCP servers workflows that we already know. So for example, I created generative AI flows for inventory, for troubleshooting, for compliance. As I mentioned before, this is, I think, important for us. We all invested time in building tools, either if those are Python, SDK, Ansible, Terraform, Go, could be many different programming languages. Or maybe we have network automation tools or CI/CD pipelines that expose APIs. And with an MCP server, I could expose all of those tools to a network engineer using a natural language interface. So I could ask, hey, I would like to provision this network device to this site. The large language model within the client app understands the tool that we are looking is provisioning, the network device host name, the site where I want to have it provisioned, and may understand that I already have a tool, could be an Ansible workflow, that I need to execute. So it's very easy. We can accelerate the consumption, all of these network automation tools with a natural language. These tools will be the tools that are already pre-approved, already tested, validated, and will be executed by the MCP server. So the MCP server and the client app don't have a lot of freedom to change. They can't change how these tools are executed. All they need to do is understand from the tool documentation, these are the parameters that I'm expecting and how to run them, how to run those tools. Some use cases, network-wide reporting. So I could create a report that includes all the Catalyst Center clusters that I manage and all the Meraki organizations, provide me an assessment of optimizations possible. Maybe I can run end-of-life reports, PSARS reports, all different kind of reports that are network-wide. So instead of me trying to get data and create reports from each of these clusters or dashboards, I can have an MCP server do that. Compliance, logs, security analysis, all of these are very important no matter in which industry we work. And again, using APIs from both Meraki and Catalyst Center, we can create reports from a compliance perspective. The MCP server collects all of this information. The agent, the client app, receives this information and formats nicely. I can instruct, I want the report to be an executive summary. I want a detailed report for the ops team, for the SecOps teams, or maybe just a high-level review for executives. Other use cases could be, as I mentioned a little bit earlier, there is a real opportunity for us to use AI tooling and MCP servers for event correlation, for reasoning and troubleshooting across multiple platforms, or even not necessarily across multiple platforms, but using information that we may need to collect from network devices directly. Something that is also important to understand, MCP servers allow us to provide through the applications best practices or knowledge base. For troubleshooting a BGP issue, these are the 5 or 10 steps that your organization needs to follow. And that information can be provided to the MCP servers, to the MCP tool. I wouldn't say the server, it's just to the agent and the MCP server. And then those are the steps that will be followed to collect the information you need for troubleshooting. The same could be for information, hey, to provision a network device or configure a network device, I need to have these minimum parameters that are required. So that's again a knowledge base, best practices that your AI tooling will follow. You just need to have it documented and instrumented within the client app, and the MCP server will execute those calls accordingly.
So that's, Gabby, where generative AI flows that you were mentioning come into the picture, right? You can build your flows by...
So that's correct. That's part of that. The other part is in the resources, we would have knowledge base. And in the generative AI workflow, I could say, hey, this is the validation or verify with the best practices document how to provision a network device or how to configure if this CLI template is matching my corporate policies. So those are, with large language models, it's very, well, it's not very easy, but it is much easier to describe using our natural language what I would like from an intent perspective, the configuration of a network infrastructure to look like. So definitely the client applications will be able to use that and instruct, basically create a workflow that matches that. Another use case, I think this one is a little bit maybe less important, but it is also important. I talked about best practices. So that's the knowledge base that is unique for each of your organization. What is best practice to configure BGP? And if that's the best practice, you can have a tool that will validate that all the routers configured for the BGP follow your best practice. But also you can get user access to user guides, and we can get access to the API documentation that is available for all the APIs across both Catalyst Center and Meraki, and we can execute those APIs. So there are other tools, and probably we'll get to a demo where we can take a look at, okay, maybe I want to learn more about an API documentation and maybe execute that API. So for the in API docs, what I have done, I'm importing the Swagger documentation from both Catalyst Center and Meraki. I am actually using all of those, the API documentation, and create embeddings. I create vector representations and save them to a library local on the MCP server. So If I have a question, hey, what is the API for getting VPN site to site, which I don't know what the API is for Meraki, I can ask the API Explorer tool, that is one of the tools that I build in the MCP server, that will search for that API from the Meraki documentation, from the vector representation. Will do actually proximity match, will return the closest matches to my query. So my query is, give me the Meraki VPN site-to-site status API. That will be basically match to the closest APIs that Meraki has for that question. And then it will be returned to the large language model, which will then answer my query. So the API Explorer matches the question I have to API documentation, to an API that may help me to basically resolve the problem that I'm looking for, or get the information I'm interested in. I have a second tool that allows us to actually call the API and record telemetry. And the tool called the API for, let's say I want to get the sites or the VPN or site or the firewall rules from Meraki. It could call those APIs and will return the information to me, and will record telemetry for all of these APIs. The reason for recording the telemetry is security is very important in each organization, but also it's important because I would like to promote, if we are all very interested in firewall rules, to understand the policies and maybe compliance, and if those rules change, then maybe we can create a dedicated tool for this. Is there a question?
No, you were cutting off there a bit, the reason for this, but then you came back. So
I apologize. I need to, I think I may have some service provider issues. I hope it will get better. Sorry for this. So this is one that I'm going to ask. How many of you are feeling comfortable that a client application, like an agent, like a cloud desktop, in my case, should be able to write or update network configuration of network devices, either managed by Catalyst Center and Meraki? How many of us would be comfortable with this?
Well, today, nobody, but tomorrow, who knows?
Yeah, exactly. I think we need to be very comfortable with the tooling and be able to learn in time and have visibility in what it would actually do, and these tools would do. And for example, in my case, I can create a new site or a new network with API calls, and I feel very comfortable, probably knowing exactly what the tool is. Probably it will do a very good job. But probably for most of us, day-to-day network configuration or updates to the controllers, probably we may not be very comfortable to use as it is the capabilities that MCP servers offer. However, if we need to run network configuration tasks, like I need to provision a device, I need to deploy a CLI template, I need to change firewall rules on a Meraki firewall, then we have the ability of the MCP server to run tools that are pre-configured, validated, and approved by the enterprise organizations with those policies. So we have Ansible workflows, Terraform plans, or Python SDK, or any programming language in network automation tools. We can ask the MCP server to use those tools for the configuration of the network infrastructure. Let's go a little bit quicker through the next couple of slides so we have a chance to actually go to the demo. So there are a couple of options we can use to configure tools, and this might be the one that allows us to be able to have a lot more control of what the tool will do when configuring infrastructure. So the first type of tools, I call them imperative. I'm going to have a predefined workflow, in this case written using the Catalyst Center Python SDK. There are a few steps. The sequence is already very clearly identified, and it will run this sequence. The large language model and the agent application cannot change this sequence. They won't have any options to basically stop the execution or change the order of the APIs and what API calls are being made. So these tools should be very good, like for network configuration. I feel much more comfortable running these tools because the only thing that the agent application has, understanding what the tool is, what the parameters are required, and how to trigger the execution of the tools.
Gabi.
In this case, for a server, for a policy verification network engineer, and then the tool will execute all the steps required to verify the policy. If traffic from the source IP to destination IP on destination port is allowed by existing policies. The other option of tools, which is a little bit easier from a development perspective, but allows a lot more capabilities also for new tools to be developed faster, quicker, is to use tools that are declarative. So I'm going to provide, like in this case, get site count or get sites. I'm providing the API endpoint. Parameters, these are all retrieved from the Swagger documentation for those APIs. And then the MCP server auto-generates the API calls, all the tools required to make these API calls. So if I'm interested, for example, in this case, I have 10 sites, and I want to get all the 10 sites information, I don't need to instrument, like in the previous case, get a Catalyst Center auth token, get the site count, get the site details for each of those sites, create a report, parse all the information. I don't need to do any of that. The MCP server will auto-generate the code and will provide me a report if I'm looking for the inventory of all my Catalyst Center sites, will provide me the information about all of those sites. I don't need to write the code. Parsing information. I provide this sequence in which the API calls are being made, but not necessarily a lot more than that. And it supports, obviously, multiple, like in this case, you can say Meraki organization. Same would be a YAML file for a Catalyst Center multi-cluster information. So tooling development is much easier because all I need to do is retrieve the Swagger documentation for an API endpoint and add it to my tools. And then next time I'm running this MCP server, it has a new tool that has been added and is available for the clients to consume. So this allows us much faster to build tools, but it's also a little bit more. The large language model has the freedom to decide in which sequence the tools are going to be called. A little bit quicker, a little bit more details on how to build these tools. For example, I have get network device count. On the left-hand side, I have the description of the API document from the API documentation. I have the parameters that are required. And that's the information that I need to provide. Again, if I want to build one of these tools, it's very easy. I can even ask Claude desktop, hey, I need you to build another tool. This is the template that I have for all my tooling. This is the API that I want you to build a tool for, and it can do it in literally a minute and be available for me. I may need to make some small enhancements, but by and large, to build one of these tools is pretty quick. Also, another important aspect is I have built in the MCP server multiple Catalyst Center clusters or multiple Meraki organizations. So if you look at this, if you are familiar with the client's API from Catalyst Center, there is no cluster parameter in the client API. But this is not the API call that would be made to Catalyst Center. This is the tool description. So this tells this API endpoint that I have a cluster parameter that I need to provide and collect information from that cluster or all the clusters. So for example, if I'm asking, give me all the clients, then it will go to both Catalyst Center clusters and retrieve the clients and create a report for me. And of course, we support pagination, and MCP servers understand. For example, if I'm looking for getting information for 10,000 clients, how many times it needs to make the API call and collect the information for all of those clients. So let's take a look at some demos. Any questions?
Yeah, so this is huge, right? I don't know if folks have managed to understand this, because the imperative way of building your MCP server, like you said, right? You define your steps. The LLM goes, looks at your server, and goes and executes the steps in that order. So this is kind of like an Ansible type of playbook, right? It goes step by step and just executes. It doesn't have the freedom of changing the steps, of doing one instead of the other. But then you have the declarative model, Gabby, like you were saying, right? So that one is, you have the API spec for your API, right? And pretty much everybody has an open API spec, all platforms, all products. So you just get that open API spec, you customize it a bit with some extra parameters, cluster, right? Could be whatever extra parameters you have. You have it in a YAML file, right? So there's really no coding up to this point. And you just specify when you instantiate, when you start your MCP server, here, your configuration file is here. And that's a description of all the tools in YAML format of what the tools should provide and what parameters they have. So you're actually not coding anything. This is, I mean, not anything, but the MCP server, right, is building the tools automatically based on that YAML file.
Yeah, and yeah, so for example, this is my description of what Catalyst Center clusters I want to use, or the Meraki organizations. I have a lab, I have a production. For Catalyst Center clusters, I have 2. If I need 5 clusters to manage, I will add 5 other clusters, other 3 more clusters here, I apologize, to the list. The MCP server code has not changed, doesn't need to change. Next time when the MCP server starts, it learns, oh, I have 5 clusters, and be able to use that. Of course, I need the passwords, user IDs, and that's in an environment file as an environment variable. But it's very easy. I just have more clusters, or if I decide for a time I don't want to use this cluster, I can disable the San Jose cluster. The same for Meraki. Here I have a lab environment, I have a production environment, and I want to learn for the lab organization the inventory. So that's very easy to create. It's very easy for us humans to build. And if I look at the configuration of the server for tooling, this is what I have. For example, for get sites, I have here the tool to get all the site count. For Catalyst Center, I created some tags to be able to group these tools and provide additional metadata to identify the tool. The information comes from the API doc, from the Swagger documentation for this API. And then I have get sites. And again, this is the API endpoint that I will call, the MCP server would call. I have specific filters, the offset and limit. I have topology. I have network device count. It's very easy to build these tools. And actually, the first time I built the MCP server as a declarative was for Meraki. And my background is very heavy on Catalyst Center. I'm becoming more familiar with Meraki APIs. But I created one of these MCP servers, the declarative MCP server, for like first 4 basically Let's take a look.
Get org ID, right? Get networks, that type of.
Yeah, exactly. And basically, this was the documentation. So I created the first in a specific sequence. I can declare the sequence in the logical sequence. So the first one is I want to get the organizations, get the networks for each organization, get the network specific network device, basic network ID details, get devices. And that's all I built, like only the first 4 tools. And then I decided, this works. It's pretty nice. It's much easier than being imperative. Write every API call, parse all the information. And then I decided, let's add more tools. So I said, okay, let's get the clients and get device clients and added a few more API endpoints, client details, client by MAC, search by MAC. So it was very easy to build these tools after the initial effort to build the code for the MCP server. So the advantage of using a declarative mode is I still have very high control over these tools because the server will advertise only these tools, but it's much easier for me to write these tools to map to the intents to what I would like the MCP server to do. So for example, if we look here, I'm going to ask, I have an imperative server for policy verification, but I have Catalyst Center tools and they are grouped based on different capabilities, makes it easier to organize tools. For example, if I'm looking for assurance information, it's very easy to see what are the tools that could be available. And I have for Meraki information, I have organization, network management, organization, network and devices. And of course, MCP servers have some other tools that are available as well. So for example, if I'm looking for more information, and now I would expect to get basically a little bit more information about each of these tools. So for example, we can see get site count and the inventory of network devices. And if we look for assurance, I have all the tools that are available from an assurance perspective. I'm looking for, let's say, interface statistics. It's available. From a Catalyst Center perspective, I have other tools for read-only commands. So this is the command runner and the sequence, get the task status detail and download the file. I have more tools from basically Catalyst Center and of course from Meraki. So this is very easy for us to understand what are the tools available, but also what is the tool doing, what will do for me. So if I'm looking here, for example, so if we look at this, I'm asking now Portland cluster. I don't know the IP address. Well, I do. It's mine. I manage it. But let's say maybe I don't.
You don't need to specify.
I don't need to specify it. Or I can do all, the keyword. Give me the list of all devices from all Catalyst Center clusters. And at this point, it will go and start to look in the tools that are available and should give me the information for the network devices. We can see the API call that is being made. The cluster is Portland. I have 500 APIs. That's the rate limit. That's the pagination. And then it gets me the information about all the access point, controllers, switches, everything that I have in my Catalyst Center cluster. It's still going. I have a few more devices to go. But it's very easy for us to have this information and look at this. It gives me, hey, there is actually a bit of a problem. There are some devices that have an error that maybe I should pay attention. And since it gave me this warning, I can ask and continue the conversation and find out, for example, are there any active issues? It starts through trying to get the number of active issues that I have. It knows the status is active in the API call. The cluster is Portland. The cluster name comes from the fact that it's a conversation. We already talk about the cluster in Portland, so I don't need to specifically state I want information for the cluster in Portland. And then it gives me the network issues. It tells me I have some BGP down problems, some EIGRP, some interface down, some device unreachable information. It tells me, it groups them, and it gives me, which is interesting, basically, it gives me an event. This is the event correlation and reasoning. And it's true, the Gigabit Ethernet 2 interface on that router has been disabled. And because of that, I have all of these other issues that have occurred. I lost connectivity to few sites and few other devices. So it definitely, without me asking, it already creates value because it will provide me insights that otherwise, they're not hard. It would be very easy for all of us to find, but this information is provided to us. I don't need necessarily to go to search for. So
So this is basically Cloud Desktop interacting with the MCP server,
yeah.
right, Gabby? This is what's happening here.
Yes. Yeah. So, okay, I see an interface being down. I'm looking for a config change for that device, and now it will look for the configuration changes. This is the device unique identifier for the Portland cluster, and it goes through the process. It will find out basically the information about the configuration changes. It will go through, download the file, and let's see if it basically provides us details about what changed there. So it looks that a user using netconf basically made a configuration change. It shows me also the archive log configuration that the interface was actually disabled. And it gives me more details about why I have all of these issues in my infrastructure. It also looks in the login activity. So it really now narrowed down very quickly that what I need to do is to enable that interface, and all of these issues should be resolved at that point. I do not have the it offers me, hey, I can run these suggested actions to enable the interface. I don't have the tooling enabled, but if I would, in this case, I could ask the MCP server, please enable the interface, and all of these issues should be resolved.
And that would be just adding to your YAML file an extra option of changing the interface, basically, or applying a configuration template in Catalyst Center.
Yeah, and we have an interface operation status up or down API. So that, unless if the interface is a trunk, in this case it's not, it could be used to be enabled, or it could be basically creating a tool to deploy a template, or I already have tooling for templates. So it would be easy to enhance this to provide that information. But let's take a look at Meraki. So now it will change a little bit. We'll go to Meraki because this Cloud Desktop has multiple MCP servers. It has one for Catalyst Center clusters, one for multiple Meraki organizations. So for example, if I search through the same Cloud Desktop, give me information about my lab network. Hill network is actually my lab organization. It finds all the organizations that I have access to. It goes to list all the networks and all the devices, and it found the network inventory for the Hill network. So if I use like what I do here, auto generation, I don't write any code like get the list of organizations. I have two, then create a loop to go through each of the network organization, each of the organizations, and get all the networks. And then I have, let's say, 5 networks in one organization and a number of networks in the other one, and do another loop to search in each of the networks, what devices do I have? So I don't have to write any of these when we use an auto-generation option, where the MCP server knows, hey, this is the API call, this is the response. I'm going to select the response that I need, the parameter in the response that I need for the next API call. If we look at the network, it will basically go through each organization ID and get the networks that are available, and then provide me, like in this case, all the devices. So it's super easy. It's very simple for all of us to use concepts like this to get quicker information that is important for us. So for example, in this case, this is the network, this is correct address, is my lab here in Portland metro area, and then the devices that I have in that lab. It gave me pretty much everything that I'm looking for. It wasn't very hard. It gave me a summary about what subnet I use, and it gives me a warning. Hey, this sensor is not running, which is true, is not operational yet.
So then, Gabby, right, there's no code. We kept saying there is a bit of code in the MCP server, actually, where you define your
There
MCP
is.
server. So
There
is that something that we can show folks? Because, I mean, yes, the tooling gets generated automatically. You just have the YAML file. But then, like you said, there's an MCP server for Catalyst Center. There's an MCP server for Meraki.
That's where it is. Yeah. So there is a fair amount of code that has been developed for the MCP server itself. And I'm going to share a simplified version of an MCP server. We'll share in the description of we'll find a way to share with you in the description of the video of the recording how to get access to that code. Will be published on GitHub. It's open source. But yeah, there is definitely some code. A lot of this code, for example, if we look here at Meraki, it's going to be, it has been developed. I have used, I'm not that good of a developer. I used Claude as well to help me to write the code, but all the ideas, everything I'm presenting, I drove the conversation and how I would like the server to be created, and really corrected Claude when it had some limitations. But for example, load organizations from YAML file. These are the organizations that I have access to. And now the MCP server will use that information from the organizations to know what is the organization and how to map to the API key from the environment variables. So there is some code that will be required, obviously. For example, in this case, there are for tooling, this is, for example, for API Explorer. Maybe we'll talk next time if we have a chance. If you, Adrian, invite me back. But there is tools. There are tooling that is available. Let's get to that. That's for telemetry. Maybe for another conversation. So this is the resources where I have the organizations loaded, and this is basically, okay, so now we are getting to the right part. So if we look here, I'm loading these tools, which are the YAML description of all the API endpoints that I would like to use. I have a default configuration in case if the tools are not loaded. I don't want the server to crash. But then I use those YAML files to actually auto-generate all the tools that I'm going to use. So for example, I'm going to use those tools to create the API endpoints that I want for GET, for POST, for PUT. I will organize the tools by category. So there is a fair amount of tools to list the tools to run the API calls. Again, I will share the code with you guys, and hopefully we have another chance maybe to go a little bit deeper in the tooling and how to enhance it. Maybe we'll talk a little bit more about the API Explorer and how to have tools for basically all the APIs that are available across both Catalyst Center and Meraki.
Yeah, so folks, you want to get a deeper view into the MCP server? Let us know in the comments on these things on YouTube, X, LinkedIn, and then we'll bring Gabby back, and then we'll have a deep dive into actually the MCP server piece exclusively. So the demo, I know you have a bunch of demos here, Gabby. We're at time. One last demo. We want to see the BGP one, the BGP troubleshooting, because that's a cool one.
Oh, yeah. Yeah. So we can start with this one. So it's same question as I had before, but this one is a little bit more complex. It's not as trivial like, hey, an interface is down. Of course, we are going to see a bunch of issues being created. This one is a little bit harder to identify. So if we look here, I asked the MCP server, can you verify if there are any active issues and troubleshoot, and runs one of the AI flows for generative troubleshooting. So it will go through the steps to find out the active issues, the topology, understand the devices that are impacted, execute all the suggested actions for those issues, run additional commands, like if any configuration changes. And based on that, basically for the cluster Portland, it will provide a lot of, this is basically the workflow. It will provide all the information that will be analyzed by the client. So the MCP server returns this information. The client understands there are two BGP issues, and it shows based on the troubleshooting flow, it already has some recommendations. It basically provides information that this issue occurred in the past 11 times, and it also suggests, basically it gives some additional recommendations. So basically I can ask, because this is one of the devices that is impacted by the BGP issues, I can ask the troubleshooting recommendations by verifying if any configuration changes on the device. It goes through a number of workflow for configuration changes. This is a workflow that will run command runner APIs, run the task, get the task status detailed, and download the file. And based on that information, it comes back and says the user GME basically applied an ACL on an interface. That ACL basically could be the impact of why I have BGP issues. It gives me also potential use cases that another reasons for the root cause. I'm sorry, because I delete some interface about the same time. If I ask more information about the ACL applied on the interface, it gives me that the details, and the ACL that has been applied is actually blocking BGP. So at this point, it tells me I have BGP adjacency issues because an ACL has been applied on an interface, and that ACL blocks BGP. But also the best part is giving me some recommendations. Hey, you can change the ACL on the interface. So it's in some other situation, and this is something that we need to be comfortable with, the answers might be slightly different when we run these workflows. Sometimes it may provide me other best practices, like, hey, maybe the best way in this case is to actually enable to be sure that BGP is permitted always on the interface as an ACL entry, and then you follow with the other ACLs basically rules that are required for that interface. So sometimes these best practices that are provided could be different. If I would provide a best practice from a policy perspective for the enterprise, that this is how ACLs should be implemented, then it will follow those best practices. But again, in a very short time, without me connecting to any network devices, without actually connecting to Catalyst Center, I am able to identify the interface is up, but I have an ACL issue. That's why BGP adjacency is down.
So you can basically you can have. like you said, best practices, compliance, right? All the steps that you normally do as you troubleshoot whatever your issue is, BGP adjacency or port down or neighbor down, whatever the issue is, you have a certain steps that you go through as you troubleshoot this. Well, you can expose those steps. You can build generative AI flows, like you said, Gabby, right? And then the actual LLM goes, in this case, Claude goes and runs those steps automatically for you on one device or on all the devices automatically and comes back with findings so that you don't have to do it, right? So you could go as easy as checking access lists, or you could go as deep as you need to troubleshoot the issue that you're facing, right? So you can automate
Yeah.
the whole troubleshooting scenario and steps. So for CCIE folks, right, that have been deep into troubleshooting their whole lives and trying to figure things, I'm sure you have, like best practices of what you need to do. You can automate those at this point. You can automate them and have the automation go and do at least initial checks for you and check that, hey, this is not a problem, and then you go into deeper and then you have a look. But usually you can catch most of the issues within the first steps.
Yeah, and the best part, I totally agree, Adrian. The best part, if you look here, I don't have hundreds of tools like inventory,
42, yeah.
compliance, everything. And I have so much more I didn't have a chance to show from a use cases perspective. But I have a small number of tools. I haven't built like hundreds and hundreds of tools. Probably would not be good from an MCP server perspective. But for Meraki, I have 10 tools. For Catalyst Center, really, I have 26 tools. But I can resolve compliance questions, inventory, network statistics, interface statistics, client information, PCerts, look at troubleshooting issues, understand configuration changes. There are so many use cases I can resolve with only 26, 30 tools. There are not a lot of tools that we need to get started.
And this is, Gabby, basically just you building this, right? We're not even talking if you have a team of engineers that are working on this or developers and they build an actual full-blown MCP server. We're just talking a project that Gaby took on and is like, okay, let me see what I can do with this, right? So you can see that it can go super far.
Yeah, and I know we are over time. I started with this one, and it was very imperative, and took me 3 days to build a tool. It was very nice. I'm very happy to verify policy. But then I decided this is too long. We need to find a better way. So I did a couple of months ago. I did the self-coding, the auto generation based on YAML files for all of these other tools. And after that, I realized that now we actually have the ability to scale because I can build these use cases. I don't need a dedicated tool because I want a PCerts analysis. I don't need a dedicated tool because I want to show running configuration of a device. I don't need a dedicated tool for troubleshooting. I build the basic tools, and then the complex workflows for troubleshooting uses those basic tools. But maybe next time.
Yes, we'd love to bring it back, Gabby, and then go in a bit deeper detail, especially on the MCP server. And by then, we'll also have this on GitHub on the repo, like you said. We'll share with folks so that they can take advantage of this. At least the basic one to get, just a couple of tools, and here's the MCP server, right? And then you can build on top of that, like you have done. All right, so we're a bit over time. Yes. Thank you, Gabby, so much for showing us this. This is incredible work. This is really cool. Is a whole team. You can do things faster than dozens of mortals. Shannon, thanks, Shannon, for watching this. Gabby, any final words?
We need to be comfortable with these tools. They are amazing. They are really good. Be careful. They could be very bring a lot of risk if we are not careful with what we do. But it's not that difficult to build a safe environment where we have guardrails of what the tools can do and how to use them. And remember, we always have the option. If I need to configure network infrastructure, follow an imperative model where the AI agent or the MCP server cannot change the order in which the order of operation. So there are options to do both.
Yeah, and we barely scratched the surface. We've only done cloud, right? We didn't even talk about on-prem yet, LLMs, and
yeah, we need to talk about
you
that too.
briefly mentioned, like closed environments, but we didn't really dive deep into that conversation. But next time. Thank you all so much for watching this. Hope you folks found this this discussion interesting and helpful. And we'll see you next week. We'll take a break from the Cisco month of learning. Well, it will still be learning, but we'll take a bit of deviation and we'll talk about Python typing next Wednesday. And then the week after that, we'll be back with Cisco month of networking. We'll wrap it up with Cisco workflows. We had delayed Cisco workflows till 2 weeks from now because Cisco workflows is going GA actually within a couple of days here. So at the end of this month. So we wanted to wait until that release is done officially. And then we'll bring Ed Novak and we'll talk about Cisco workflows first week of October. Well, 8th of October. So next week though, Python typing, best practices on using Python. So it's a bit more developer oriented and some of the best practices around Python typing. So join us next week. Gabby, thank you so much again. Thanks, folks, all for watching. We'll see you on the next one. Take care, folks, and see you on the next one. Bye.
Thank you so much. Reach out to us if you have questions or we can help.
Exactly. Leave comments. All the social media platforms, we're watching them. And we'll reply to them as soon as we can. Thanks, folks. See you on the next one.
Bye, everybody.